In order to observe the Stirling engine in motion, we followed a set of procedures. We first measured out the water into a water heating device, and for this we used a coffee pot, and then we heated the water. Next, we poured the water into a mug, and we placed the Stirling engine on top of the opening in the mug. Then we slightly turned the wheel of the Stirling engine counterclockwise and watched it spin. Next, we observed the Stirling engine in motion and recorded data such as photos and videos. As you can see here, this is a Stirling engine in motion, and whenever someone tries to stop it and accelerate in the opposite direction, it continues to accelerate in the counterclockwise direction. So this video just shows the Stirling engine working, and as you can see, the piston is moving up and down, which causes the wheel to spin in the counterclockwise direction. The Stirling engine is a heat-powered engine that works due to the convection or movement that occurs when hot air encounters colder air. Because hot air is less dense than cold air, it naturally moves above and expands. The constant movement expansion causes the piston to move up and spin a wheel, thereby converting the movement of particles in a gas into mechanical energy. And this is a video taken with the thermo camera to show the movement of hot air and the heat that occurs within the Stirling engine. Placing a hot cup underneath the Stirling engine causes the wheel to accelerate in only one direction. If it's spun the opposing way, it won't accelerate, and this is because the heat exchange occurring within the cylinder happens in one direction as well. The hot air or steam from the coffee cup moves to the top of the cylindrical compartment, and the cold/room temperature air already existing there moves down due to densities. This heat transfer setup causes the flywheel to spin clockwise because the lower plate is the heat source. It will spin anti-clockwise if the upper plate is warmer, and the flywheel experiences acceleration as the heat permeates the bottom plate. Eventually, the wheel would stop due to all of the air cooling. Overall, the Stirling engine demonstrates the transfer of heat energy to mechanical energy, as the compression and expansion of gases causes a piston to move vertically. The Stirling engine can be used to teach thermodynamics and the isothermic expansion of gases. For the future, cold air can be propelled onto the bottom plate to further observe this cycle. In addition, many variables such as the hot air's temperature and the outside temperature can be manipulated to calculate the acceleration of the wheel. As seen from the demonstration, density plays a crucial role in the continuation of the engine and the progression of the cycle. Stirling engines are not usually seen in today's world because of its inefficiency. Stirling engines take up a lot of energy to heat air, when steam engines take up less energy to heat water. However, submarines use Stirling engines because Stirling engines are silent and submarines need to be secretive.